Okay, so we are ready to officially start factoring a polynomial expression using the GCF rule. Remember, polynomial means many terms. So my first expression is a cubed minus 9a squared. Now understand why I'm saying factoring now and not simplifying. If I said simplify, it would mean do the operation you see, which is subtraction. And we cannot subtract these terms because they're not alike. An a cubed is not like an a squared. We've already learned that concept. So that's why now the directions say factor. The GCF rule is the first rule you always try when you hear the word factor. You will look to see if all the terms have something in common, whether it be a number or variable you could divide them by. So let's start. What's understood to be the coefficient in front of a cubed? It's a 1. So with 1 and 9, what is the only number we could divide them both by that they have in common? It's a 1. Okay, so we take the 1 out. Then we look at the variables. I have a cubed and I have a squared. A cubed means I have 3 a's. A squared means I have 2 a's. What's the most they each have in common? That's 2. So the rule is when you're doing the GCF of a variable, you take the term with the smaller exponent. So we take the a squared. Now, you're not done factoring. All you've told me is what the GCF is. Now you're going to put parentheses and tell me what's left. And the way I do this so I don't make a boo-boo is I actually show what I'm about to do. To figure out what's left, you're going to divide each of these terms by the GCF. So I'm going to physically write, all right, I got to divide by 1a squared, I got to divide by 1a squared. And I'm actually going to do the division. A cubed divided by a squared, I would subtract my exponents and get a. Negative 9a squared divided by 1a squared. Well, negative 9 divided by 1 is negative 9. And when I divide an a squared by an a squared, it cancels out. This is your answer. This is in factored form. It's connected by multiplication. Now, is there anything here written that is not necessary? Good. The 1 is not necessary. 1 times a squared is just a squared. So in factored form, this expression is a squared times a minus 9. That's what we're looking for. Now we know that's right because we could check it by using our distributive property. What's a squared times a cubed. What's a squared times negative 9? Negative 9a squared. As long as you multiply and get back to the original expression, you factored correctly. All right, let's go to our next example. I have a trinomial here, 1, 2, 3 terms. I'm not saying simplify because simplify would be to add or subtract. And I cannot add or subtract these terms because they're not all identical. This is an x squared yz cubed. This is an x to the 4th yz cubed. They're not alike. That's why the directions say to factor. The first rule of factoring is GCF. What do these terms have in common that we could divide them by? So start with the coefficients. 4, 6, negative 10. Well, we know they're even numbers and they're all divisible by 2. So we take out a 2. Okay? Then we would do the variables. X squared, x to the 4th, x cubed. What's the most they all have in common? If you had $2, I had $4, and somebody else had $3, the most we could each give is the $2. So x squared, the term with the smaller exponent, is what they have in common. I have a y, and a y. Those are all y to the 1st. So that's what they all have in common. I have a z cubed, but this expression doesn't have a z at all. So, ladies and gentlemen, you cannot take the z cubed out and say it's part of the GCF. GCF means what all the terms have in common. This term does not have a z cubed, so we cannot take that out. So our GCF is 2x squared y. But you're not done. This is still not written as multiplication. We're going to need a parentheses to tell me what's left when I divide each of these terms by 2x squared y. So I physically write it under here. I'm going to divide by 2x squared y. I'm going to divide by 2x squared y. Divide by 2x squared y. Now I'm going to do the division. 4 divided by 2 is 2. X squared divided by x squared cancels out. Y squared divided by y squared cancels out. and then I have the z cubed. Positive 6 divided by 2 is positive 3. X to the fourth divided by x squared is x squared. Y divided by y cancels out, and I still have the z cubed. Okay? Negative 10 divided by 2 is negative 5. X cubed divided by x squared is x. Y divided by y cancels out. So if I look here, this is my factored form. I have the GCF in front, and I have what's left over when I divide that GCF out. If I want to check, I would distribute. 2 times 2 is 4. X squared, y, z cubed. 2 times 3 is 6. X times x, x squared times x squared is x to the fourth. Y, z cubed. 2 times negative 5 is negative 10. X squared times x is x cubed. And then I have the y. Let's try one more expression. Pi r squared minus 2 pi r h. Again, I can't say simplify because that's subtraction, and these terms are not alike. That's why the directions say factor. Remember, pi is a symbol that stands for the number 3.14 approximately. So we're going to see pi a lot in algebra. GCF is telling me to find what these terms have in common. Well, they each have the pi symbol in common. This expression has r squared, 2 r's. This expression has r, 1 r, so the GCF would be the 1 r, the least. Then we'll say what's left. I like to figure out what's left by doing the actual division. Divide by pi r, divide by pi r. Pi divided by pi is the same thing as dividing 1 by 1, dividing 2 by 2. Something divided by itself cancels out. R squared divided by r is r. When we divide, we subtract exponents. I have negative 2. The pi's are going to cancel out. We're dividing the same amount. The r's are going to cancel out. We're dividing the same amount. And we're left with h. And this is your factored form. So your factored form in algebra always shows the GCF in front and what's left over when you divide it out in the parentheses. And that's factoring because you now have rewritten every expression as multiplication. Okay, one rule down, 4 more to go. See you in the next video.